One kind of JCE or Java cryptography extension algorithms are based on synchronous communication, and there are ones that are based on asynchronous communication. So in a synchronous communication, you want to be able to generate a key, and you will encrypt and decrypt based on that key. Once the key is generated, anybody who has the key can open it. On the other hand, the asynchronous communication is that opening key is different from closing key. So that basically works on public and private set of keys. That's a totally different kind of encryption and decryption algorithm. Sometimes to make things more secure, we also apply hashing. So hashes actually converts the data into some kind of a unreadable data set. And then using that, we can then generate our encryption algorithm. Also, there are different levels of encryption algorithms. There are 256-bit encryption algorithms. There are 128-bit algorithms. There are 64-bit algorithms. So and then some approaches are older approaches. Some approaches are newer approaches. The older approach, it was DES approach. So what I want you to do before we start working on this stuff, I want you to open a web browser and go to a search engine. And I want you to start looking at DES encryption. And then I want you to read about AES encryption. Those are the two different kinds of encryptions we want to talk about. So let's take a few minutes and you guys can read about the DES and AES encryptions. So to get started here, I would like to create a new class, and which we'll call Java Cryptography Extension Example 1. So I'll be using 1, and this will be my DES approach. First example of my DES approach. So JCE is a framework and implementation for generating key and encryption, decryption of data using various algorithms. That's what JCE does, Java Cryptography Extension. And one of those algorithms is Java DES approach, and another is the AES approach. And what exactly do we mean by encryption? Encryption is basically a process in which we translate plain text into something that appears to be random and meaningless, which is called the ciphered text. Then we decrypt it by converting the ciphered text back to plain text. That's basically what encryption decryption does. What are the steps that you would take when you are converting your DES, encrypting it and decrypting it back? Let me write down these steps for you one by one. First of all, we need to get what we call a key generator. That's step number 1. So that we can generate a key based on which we'll be ciphering and deciphering, or encrypting and decrypting. Step number 2, we need to generate a secret key that will be used to encrypt, decrypt. Step 3, you get the cipher instance to use the DES algorithm to encrypt and decrypt. Then there are 2 kinds of cipher objects that you can create. You can create a cipher output stream object to encrypt and cipher input stream object to read that cipher and decrypt. So that's basically the gist of the process that we will be going through in this example. So step number 1 would be to use key generator. Step 1. Key generator equals to key generator dot get instance. And this is where you need to define what algorithm you'll be using. So to my key generator, I'm saying that I will be using a DES algorithm approach. Now, this error that I have around this is because of the reason that I cannot write this code without a proper try-catch block. So I will incorporate this in a try-catch block. And of course, there are different kinds of catches that we will write. When we get that far down in the catches, I will be writing those. So we will know. Okay, so that's step number 1. Key generator is done. Now in step number 2, I have to generate a secret key based on the key generator. So secret key generator dot generate key. Step number 3, I have to get my cipher instance. So this is my cipher instance based on the DES standards. So this line will need some explanation. That's why I'm stopping on this line for some time. There are 3 sets of items that you need to understand. These are the 3 things you need to understand. So DES is data encryption standard. Then what is ECB? Electronic code book. Let's first understand what that does. So the cipher supports two kinds of modes. One is called the ECB mode, and the other one is called the CBC mode. And again, remember, DES is an algorithm that is effective on 56-bit, but it can be used at 64-bit. However, the 8 bits that it cannot use between 56 and 64 are because of the parity. So they're reserved for a reason. So you can only use 56-bit. So it's not as secure and as strong. So it uses two modes, ECB mode and CBC mode. And on top of that, when you are using either of the two modes, it needs to do padding on the data that you're sending over. And these padding could be either no padding, that means I do not want to pad my data with anything, or you can use the PKCS5 padding approach. So with this combination, you can make total of 4 combinations. One combination will be DES, ECB, no padding. Another combination will be DES, CBC, no padding. Third combination will be DES, ECB, PKCS5 padding. And fourth combination will be DES, CBC, PKCS5 padding. So you can use 2 modes with DES, and with each mode, you can go no padding or PKCS5 padding. Now, what is the main difference between no padding and PKCS5 padding? In no padding, you have to make sure that when you are sending the data must be in multiples of 8 bytes. Either 8 bytes, 16 bytes, 24, 32. It has to go like that. Otherwise, the encryption or decryption will result in truncation. If you send 25 bytes, then the other party will not receive the 25th byte. On the other hand, with PKCS5 padding, you can send data in different lengths. That's why I would prefer to use PKCS5 padding. How do you use these paddings? You make DES, ECB, PKCS5 padding. That's how you tell how you want to cipher the data. Does that make sense so far?
Yes, but is it bytes or is it bits that it passes?
Bytes.
Bytes.
Bytes. Yeah. Okay. So now that we have created ciphering based on the DES standard, now we need to use this ciphering to initialize a cipher for encryption purpose. Using the key, which is a secret key. So using the secret key, I'm initializing a cipher. Okay. Now, let's work with a data. The data has to be in a byte form, so I'm creating a byte array for that. Let's say I come up with this data, code 789. 3, location, jet cars. Go. That's my code. Now I'm going to send over cipher. So just so that you know, this is how before ciphering, this is how the text appears. Now, let me encrypt this. This is the encrypted text. This is the encrypted text. Now, let me write appropriate catches so that we can test this code this far. Okay, let me test this. Okay, here you can see when you run it the first time, the before ciphering text and after it got ciphered. Everybody get to see this?
No, mine doesn't have any errors, but it doesn't have any output.
Uh, hmm. And you have lines 35 and 39 exactly the way I have them?
Yeah.
Okay. Let's have a look at yours then. Oh, on line number 29, it is ECB.
Oh, that's just an error. Okay. All right.
PKCS5 padding. Okay, go ahead, run it.
Yep, there we
you
go.
Okay.
Okay, thank you.
Actually, since we didn't write anything in the error handlers, it did not pop out that it was actually, if we would have written a message there,
Yeah, yeah, yeah.
it probably would have said, that you have a wrong padding type or something.
See mine.
Did you say something, Emka?
Yeah, can you see mine? Because mine doesn't work.
Okay. Okay, let's see. Line 12. Can you scroll up for me, please? Further up, all the way to the top. Okay. Let me check your, okay, so you have cryptos, cipher. You're missing something. Go scroll down. Scroll down to the bottom. Okay, yeah, you're missing you need to get rid of that, right? No, you need to get rid of one of the curly braces, right? Okay.
He's also missing the bad padding exception.
Yes, yes. So you need to copy lines 48 and paste it on line after that. Yeah, copy the entire line 48 and go to the end of the line and hit enter and paste it. And then
And it's mine.
yeah, and then change it to bad padding exception. Anyway, bad padding exception. Okay, organize your imports. Okay, run it. Okay, cool. You got it.
Thank you.
Anybody else? Or everybody else got it?
Can you just scroll up? I'm trying to get all the catches, and
Okay.
I think I'm missing something.
Oh, okay.
Thank you, I got it.
Okay, cool. Anybody else? Everybody else got it? Okay. So everybody is able to change the plain text to a cipher text. Okay. Now let's decrypt it back. So we'll decrypt it here. So first of all, I need to open the cipher for decryption mode. So I will open the cipher on decryption mode. Once I do that, I'll create a byte array. For example, I'll call this one text decrypt. And it will cipher, do final, but this time, what am I ciphering? The encrypted text. So, and then display the decrypted text. So now when I run this program, I get the same text back after ciphering. So I take the plain text, I cipher it, and I decipher it and I display it.
Hey, Saad, can you remind me what the key command is to organize your code again?
Control Shift O.
All right, thank you.
Okay. So everybody is okay with this one before we can look at AES approach?
Would you mind scrolling back down? I just need to finish that up.
Oh, sure. Here we go.
Thank you.
Mhm. Okay, so if everybody's done, we will now move on to our next example, which we will start by creating our AES example. So we're going to call this one my AES app. So what I'll do is I'll create an AES app and I will share what I create over here. I will utilize that in another program. So we'll take that approach, and in this approach, we will not create a main method. So we will do that through another program. So this is the class my AES app. So I'll take a modular approach in this example to create my secret key and create my message digests and all of that stuff. So to make it all happen, I will create some global static entities, which could be shared across the methods. And one of them is secret spec object, which will act like my secret key, secret okay. We'll create a method to generate the secret key. We'll create a method to encrypt, and then we'll create a method to decrypt. So we'll just modularize the whole approach as opposed to putting it all in one place. Public static void set key. And we will pass that key from the main that we want to use as an encryption key. So instead of hard coding the key inside AES, we want to be able to control the key. So that's why I'm creating it as a separate program. So I have the control of passing the key and controlling it. So I will use the key to generate my secret key spec object. So my key dot get bytes UTF version 8. Let me do a try catch. No such algorithm exception and unsupported encoding exception. Oh, encoding, not coding. You guys know what is a message digest? Anybody knows what is a message digest? You guys ever hear about it or anything?
Doesn't sound familiar.
Doesn't sound familiar. Okay.
Only know what a Reader's Digest is. That's about it.
So again, Reader's Digest.
A Reader's Digest. That's about it.
Okay, what
I'm dating
basically
myself.
it is a fixed size numeric representation of the contents of a message. So what you do is you take your message and you produce a number equivalent to that message. And how we do it is we do this with the help from a hash function. And that leads me to my next question, or your question. What in the world is this hash function? It is a function that produces checksum. So, well, what is a checksum? It is an error detection mechanism. So when data is sent from one end to the other, checksum can compute a numeric value equivalent to the data set and will convert the value before and after the transmission and can tell you if the value was changed during the course of transferring. So that's what the checksum can do. So hash function uses checksum to generate a numeric value on the data set, which is called message digest. And again, there are several different algorithms to generate message digest. And we are using one of those algorithms called SHA. Okay. So I have the key, which I created from the bytes. I will now use the message digest to create a digest for me. And I will use the key, which I have now, to generate a new key. So I'm using the bytes key, and using bytes key, I'm generating a message digest, and that will be the new value for the key. And what I will do, since these keys are long, I will only copy the first 16 bytes out of the key into the key. Okay, now it's time for my secret key object to be instantiated based on this key. So, and I'll use the AES algorithm because that's what this example is all about. So those are just the steps to generate my key. Next, I will write my encryption method. So first of all, anybody who calls the encryption method will be passing a string to encrypt and a secret key. I can call set key, which is the method I declared up there, and I can pass that secret key based on which the secret key will be generated. Once the secret key is generated, now comes the whole ciphering process, which is exactly the same between DES and AES, except for how the key is generated. So I'm creating a cipher object, cipher.getInstance. Okay. Remember in the previous one, we created a cipher instance on DES, ECB, PKCS5 padding. Everything will be the same except for the DES will be replaced with AES. Will be an AES padding. Also, in the previous example, when we were initializing the cipher, we were using the encryption mode and the secret key. We'll have the same idea here as well. So we will use our cipher object to initialize the cipher on the encryption mode using the secret key. This guy, secret key. and we will return this encrypted text
What does set key do? In line 35.
Oh, it makes a call to set key method.
Oh, that's right. Okay,
yeah,
all right.
yeah. And that helps us create our secret key.
I gotcha. Thank you.
Now, inside the do final, I will pass the string that I've received from the, that I will receive from the main. I will use this to convert that into, sorry, bytes. So that plain text will be converted into an encrypted text and return back. I'm not writing my decryption method yet because I want to test this much. So once everybody is done with this code, then we will write a different program from where we will call this method to see if it'll help us encrypt the code. And then we will, you know, come here and write the decryption method and test it again. So that class will have a main method. JCE1 AES1 is the name of the class. And this is where I will create a string with my secret key. This is the secret key that I will pass that will be used to create my cipher. So for example, I can come up with my own key like do not speak about that. Okay, that basically is my secret key. Okay. And here is my original string that I want to cipher on this key. Secret site HTTP 10.67.56.33. That's the secret site that first I want to encrypt. So my AES app, which is my AES app, dot encrypt the original string and the secret key. Okay. Now let's see the original text. And the encrypted. And let me test this. Here we go. Okay. So I was able to encrypt this using my own secret key. Except for Amka, everybody else got it.
I got null for mine.
Okay. I will switch over to my AES app and check your code here to make sure that you pass the correct ciphering information.
What did you say?
Check to see if you have this code correctly. The encryption code, lines 35 through 38.
Turn best encoder dot encode string cipher do final. Yeah.
Yes, you have it correctly, though exactly. I
Yeah.
have it over here.
Mm-hmm.
Your get instance is matching too.
Yeah.
Okay. And this line is also correct.
Yeah.
Okay.
You want to see?
Let's have a look at it. No, Ismail, no. It will be different because it's all message digest. It hashes everything differently. See, I told you, you have it wrong.
Is it this one?
No,
Which one?
I'm not telling.
Can I tell them what line at least?
You check and figure it out.
Can I
It's
see?
only 4 lines, man. Come on.
Can I see your code?
Yeah, it's showing.
I can see it.
You can't see my code?
No.
See
Okay, I
now?
can see now.
Did you find it?
No.
Come on, it's so evident.
Can't see anything. They all look the same.
Did anybody else spot it? Amka's mistake?
Ah, I got it. I got it.
One
No.
wa-
No, I didn't get it.
Huh? Did anybody else spot it?
Oh,
Amka's
it's
mistake?
PKA C5 padding.
Yeah, you're missing S. You wrote C5 instead of CS5 padding.
That's crazy.
Somebody else also had null? Or everybody got it now?
I have null still, and I changed mine to PKCS5 padding.
Maybe it's something else for you. Let's have a look at yours.
Okay.
Ah. Okay, I'm not telling you either. That's so evident, guys. That is so
Oh, I see it. I see it.
okay, cool. In the meanwhile, I will copy the encryption method and paste it to create my decryption method. The decryption method is very similar to encryption method. Let me change this variable name so that it makes sense. String to decrypt. I will still be setting my key on the same secret key. However, where do you think I should make change?
Probably in the initialization to decrypt mode.
Yeah, so that's one change. The other change comes in on line 50. I cannot return base 64 because it is not encrypted. It is a decrypted plain text. Rather, I need to return a string. And in that string that I will be returning is where I will be taking my cipher do final base 64 dot get decoder dot decode string to decrypt. Okay. Now let me write the decryption code here. So string decrypted site is my AES app dot decrypt. This will receive an encryption site on the secret key. So my decrypted object is this. And I get my same text back. Okay. So those are the two different approaches for encryption and decryption. And now I want to move to our next topic, which is about multi-threading. What is multi-threading? Why do we write multi-threaded apps? Well, basically, multi-threading allows you to run different threads on your computer. And what is a thread? A thread is a lightweight process. What does that mean? That means your application, which is a single process, can be run faster by dividing it into smaller, more manageable processes called threads. And these threads will run simultaneously on multiple CPUs on your computer, where different CPUs will pick up different threads and your application will run much faster, as opposed to waiting in queue on the same processor. It could be simultaneously processed by multiple processors. And our next set of examples that we will be working on for some time today would be to start looking into how you can divide your main process into smaller, more manageable processes. Actually, so far, you guys have created a single threaded application this far. What was the name of your thread this far? Can anybody guess? What is the name of the thread that you have used this far in your single threaded applications?
The application thread.
No, no.
Eclipse.
No, I've already given you the answer.
Main.
Single thread.
Say it again. Somebody else said something before the last answer. Ismail. Yes, it is main. I already gave you the answer, right, guys? I purposely selected the word main, if you can see on my screen. It's the main thread. So anytime you create a program with a main thread, your application runs. If you do not have a main thread, your application doesn't run. That's the single threaded application. That's called the main thread. So what we will learn is how you can create other threads from the main thread and create a multi-threaded application. Okay. So we will start out with something as simple as creating an instance of a thread class and running it. So let's create thread example 1. So we'll create an instance of thread type, just like that. So I create an instance of thread type. I am using that instance of thread type to get the name of the thread. Here's the default name of the thread. It is thread-0. First instance of thread running from within the main thread. Now, somebody may be wondering, okay, how can I see the main thread? Can I even see the main thread? Yes, you can. We will see that. Can I see the name of the main thread? Yes. We will pull the name of the main thread out of the main thread, and we'll take the same approach. We'll say string name2 equals to thread dot current thread dot get name. So the current thread is always the main thread. Name of the main thread is name2. And here you can see the difference. The thread that I created as an instance of thread class, that's called thread0. And the main thread has the name main. So right now I have two threads running. One is thread and other is main. Can I change the name of the main thread? Yes, you can. We can say thread dot current thread dot set name to Alvin.
Yes,
You are main.
I'm main.
I thought you
Oh,
were
yes,
referring
okay,
to
yes.
Alvin and the
I didn't realize
Chipmunks.
I typed my own name.
Okay, everybody got this one done?
I need to write the last line.
Okay.
All right, I'm good.
Awesome. So now let's save this example as thread example number 2. And instead of doing everything in the main, I want to have a method so that you can see how threads can be passed as a parameter. We're going to call this method print, and I'll pass a thread object.
Wait. What did you do?
I save as the previous one, which was thread example 1. I saved it as thread example 2 by clicking on File, Save As.
Example 2.
Yeah, thread example 2. Okay. And then I rename line number 2, and I'm writing a method print.
Well, I didn't get it. What the?
What did you not get it?
I don't have my saved example too.
So this method will print the name of the thread that whichever thread I want to print the name of. So instead of line number 7, I can just simply make a call to print and let the print the name. And I could repeat the same, over and over again. Okay. Oh, not name, sorry. I can pass thread, not name. Okay. So I can pass thread and I'll do the job for me. Okay. Similarly, instead of doing this, get name, I can just pass the whole thread, the current thread, to the print, and it will automatically pull out the name for me. Or I can change the name of the thread, and I can pass it again for it to now show me the updated name. This line is not needed. Okay. So here I am passing the default thread. Here I am printing the current thread. Here I'm printing the current thread after the name change. So this line is printing this. This line is printing main. And this one is after a name change is printing the last one. Okay, everybody got this change? Okay. Now let's move on to our next example, where we will create a class which will be a child of a thread. And why would you want to do that? The reason we would want to do that is all the thread examples that we have seen so far, we were utilizing the original thread object. Line number 5, we created a thread class object, but it was not a customized thread. It was not my thread. It was using the thread class as it is. If I want to create my own thread based off the thread class, I would custom thread it. Now comes the question, why would you want to do that? Why would you want to do that? Now remember, when you have a thread, thread is a lightweight process. What does that mean? That means you would want to be able to control the process. Like sometimes you want to speed up the process. Sometimes you want to slow down the process. Sometimes you want to prioritize the process. You can't do it with a standard thread. For example, you guys might have created a stopwatch in C#. Have you guys ever done that? Stopwatch in C#?
I don't remember us doing
Okay,
that. I think
okay.
we were mostly doing form applications.
Okay. Okay. Like, I don't know. I mean, since I don't teach C#, I don't really know what you cover. But sometimes, you know, instructors make you do those examples. That's why I asked. So how does a stopwatch works? Does anybody knows?
Counters?
Yes, and that counter is based on?
I think it's based on minutes, seconds, milliseconds.
Exactly. It's based on time. How often does it records time and reports it to you? After a delay. That delay could be set to milliseconds. That delay could be set to seconds, you know? So how do you control a delay? Through a thread. You create a thread and you make the thread read the time after a certain delay. And after it reads the time after that delay, it reports the time to you. Now, with modern computers, since you're reading text and writing text, there is a delay in thread delaying, reading and writing, but that is in nanoseconds. You don't even feel that latency and delay. It's almost real time. So that's exactly what threads can do. They can delay the processes, but you cannot make your main process get delayed. You have to be able to create other processes or other threads of your main thread, and then they can control the delaying logic. Does that make sense?
Sort of, but I have a question when it comes to delays. It's a little bit of a digression, but I always wondered how it's coded to where when you like, so for example, you launch an app on your phone and you go to type in like a text box or whatever, and then right as you're going to type into that text box and press your thumb on the screen, an ad pops up. So like when you launch an app and then like 3 seconds later, the ad finally pops up just as you're about to click into a crucial area where you need to be. You get what I'm saying?
Now that is something that is controlled over a web server, but again, that's only possible through multi-threading.
Okay.
Yep.
Thank you.
Yep. Yeah. Anytime multiple activities are happening at the same time within an application, it's only because of multi-threading, because you cannot split a thread. So, for example, have anyone of you played an online game?
I have.
Yes.
I may have played one or two in my days.
Yeah. Now,
I didn't even think those were possible.
the online games, have you ever played an online game where other people were playing and you joined?
Roblox,
Yes.
servers on
Exactly.
CSGO.
And so many people are roaming around the same plane. And if one of them decides to exit the game, does it crashes the game?
No.
No. Okay. So that's basically multi-threading working. So there's a game plane on which every user that attaches the game over a network is a thread. So when the thread decides to leave, only that thread leaves because the game is getting played in the main thread. The subthreads can join, the subthreads can leave, but those threads coming in and leaving do not disrupt the game because they are not the main threads.
Yeah, that actually makes sense.
Okay, so what you can do is, what we will learn again when we're going through the multi-threading process, is that we can create a pool of threads and we can set limit to it. That's why sometimes what happens when you're trying to join a game, it says it's full. Have you ever run into any of that situation where it says,
Yep.
it's full?
Yeah.
Yeah.
That's what it is. The thread pool is full because they know their server can only take maybe 2,000 users at any given time. So they create a pool and they limit it. So if the pool is full, the pool doesn't has any more threads available to give to you until somebody leaves. And it creates a space. And then you can come in and the pool will assign you a thread. Similarly, in a multiplayer game, besides from multiplayer game, in a single player game, when you run into a plane and you are shooting objects or you're shooting other objects there, and an object dies out. When an object dies out, the game doesn't crashes. The reason is the dying out object is a thread. It was on the plane and it was moving around as a thread. You are moving around as a thread, but you are connected with the game. And the condition is if your thread dies, the game will not crash, but the session will end and you'll be kicked out of the game. But if any of the other threads die, which are controlled by the computer, main thread, then only that thread leaves the thread pool while the main thread still continues to play the game. But if your thread dies, the main thread then closes the stage or the session and kick you out. But you don't leave the game software, you only leave the scene to start again. So all of these activities are actually controlled through threading. That's the only way possible for us to truly create multiple processes running on the same plane where some processes leave while others are still there. In the good old days, when we used to do everything through one single process, it was very difficult, especially if you had one processor. That's why the games were so much slower and 2D, and we didn't have the muscle power in the computer to be able to do the multi-threaded application. That's why consoles became very famous, because computers couldn't do what consoles could do. Anyway, you got the idea, right? You get the idea. So let's create a custom thread. And that will be a child of thread class. So that's why I went next to superclass browse button. I clicked on the browse button and I typed the word thread. And this will be a public static void main. So my class will be a child of thread class. So I want to be able to create my own constructor. So I want to have my constructor such that I want my threads to be able to have some kind of a name that I can set, which I will then pass over to the constructor of the parent, which sets the name. Now, all of this stuff, I don't know if you remember it not, but we cover it in Java 1. That super is a call to the constructor of the parent that takes the parameter that you are passing. So in this case, we are calling the constructor of the parent that takes one parameter, and that's how you can give the name to your thread. So we have, so that we are calling that, okay? Then we need to start the thread. How do you start the thread? You start the thread with the help of a start method. So start method is a built-in method in the parent class. Start method calls run method. And that's important to know. Run methods is responsible for the action of a thread. So whatever the thread does, that's the job of the run method. And run is also a built-in method of thread class. Now that leads me to my next question for all of you. If you want your thread to do something different than what the parent method does, what would you do?
Do you override it?
Very good. Exactly. That's why I want to override the run method by creating my own version of the run method. So as a result, when I call start, the start will call the local run now instead of calling the one in the parent. So this is what I want to do. I want to run a loop that will run for 10 times. Thread dot current thread dot get name thread here. And then I will make the thread sleep for 1 second. So, and I'll do that for 10 times. So my application will definitely run for 10 seconds for sure. And when I'm done, then I would like to thread dot current thread. I want to tell the user that the following thread is now ending. And of course, when I'm using sleep method, I have to write a catch. I will let you guys finish this much, and then I'll talk what kind of catch I want to write and why I want to write that catch. The body will be empty, not to worry about that, but it is the catch type that I want to talk about. Okay, is everybody done so far? Caught up? Now, my question to you is, when your computer is acting slow or not responding, what is it that you do to make sure that it is not completely dead?
Bring up task manager.
No, that's more of an extreme.
Move the mouse.
Yes. Why?
Oh.
Why you do that?
Wake your computer.
Well, the computer could be woken up by Alt Control Delete too, but you'll see that people go for mouse.
Trying to test how responsive it is, like if it responds.
Okay. Why don't you press a key to check that?
Because there's
'Cause you
no
can-
visual indication.
So again,
Because the mouse is an easy visual indication.
you could press a window key. That could be a visual indication. I'm going to pop up a Windows start button, but nobody does that. Why? Because mouse is the highest priority thread. When you move the mouse in a graphical user interface environment, the operating system leaves all other processes and attends to mouse. If after moving for a few times, operating system is unresponsive to mouse, that's an indicator that it's frozen. Otherwise, it would have responded back. Okay. So what happens when your operating system is doing something and it feels like it's frozen and you move your mouse and it leaves everything and attends to the mouse movement? What do you call that? You call that an interruption. Okay. Similarly, on line number 18, when I make my thread sleep, what will happen after 1 second? It will wake up. Once it wakes up, it would want CPU to give it the attention. CPU at that time may be doing something else. As a result, if there is a conflict, then interruption exception could occur. That's why we capture that exception. It's interrupted, not interruption, interrupted exception. Okay. Now, let's get to the main method. In the main method, we will create some unnamed custom threads. Like, for example, Sleepyhead 1. Okay. And let's create, Sleepyhead 2. And create a Sleepyhead 3, right? And now let's run it. Watch the output. Okay. Even though I said there must be a sleeping of 1 second, but notice I see some delay, but it's not really 1 second. Because one thread is sleeping, the other runs. When that sleeps, the third one runs. And since I'm working on a machine that is multi-threaded, not all threads run at the same time on the same CPU. Rather, they're distributed across multiple CPUs. And some CPUs run faster than the others because of the overload is less on them. As a result, different threads will start at different time and may probably end at different time.
I have an error.
So again?
I have an error.
Okay. Did you try to solve it yourself?
Yeah,
Do you really want me to look at it?
100%.
Hey,
What?
go ahead, share it.
There was an easy.
It's
there was
not
an easy-
it's not yet it's saying it's loading, so okay, now it loaded.
It says there was an easy fix, and I pressed on it and deleted this line.
Okay. How about you save your changes? Save the changes.
Okay.
Okay, you done? Okay. Now hover over the line that has an error. What does it say?
Few fix available.
It says unreachable code, right?
Oh yeah.
That means this code can never run. Why? Look at your line number 17. Start reading your line 17, word by word.
For int I equals 1.
And
1 is less than and equals to 10.
1 is less than equals to 10, or should it be
Oh,
I?
is it I?
Ah,
I.
yes.
See, I couldn't fix it by myself. You see that?
Yeah, see, here you go. So if you try running it a few times, you may notice that the threads will start in different sequence and may probably end in a different sequence. Like my thread start 132, but ended in 312. My previous run, they started at 312 and ended at 123. So it's all random. It's not, nothing is fixed. Everybody got it? Okay. Let's take a break here. When we come back from break at 7:45, we will then start looking at how you can run multiple threads and make them join before everybody comes to an end. Okay, so we will do something similar to this one, but we will write more code and expanded code to this one. Well, so I will see you guys at 7:45. 7:45, 7:46. Okay, 7:46, Greg.
Trying to get an extra minute in.
Yes. Welcome, guys. It is 7:46. Everybody is back. Yay. Awesome. Let me clear everybody's feedback. Let me share my screen. We will get started. And you know what? I forgot to do the attendance. So let me quickly take care of that. In the meanwhile, if anybody's still in the process of joining, can join after the break. So we have Aiden here. We have Nathan Boots, right? Nathan, yes, okay. Ismail is here. Caden. Do we have Caden? Yes, Caden is here. Jonathan is here. Rally.
I'm not here.
Rally's here. Amka is here. Daniel is here. Cody's here. Alexander is here. Miguel. I think I saw him.
Here.
Here, yes, yes. Bart is here. Mason. Do we have Mason? Yes, we have Mason. Okay, Greg is here. Of course. And Desmond is here. And Carter. Do we have Carter here? Is here? Alvin is here. Amruta is here. Everybody's here. Awesome. Okay. So let's get back to where we were before. And that was having fun by writing multi-threaded application. Ha! I can be a poet some days. Okay, so this is the app that we were working with. And I told you before we went on break that we will make some changes to this one to make it a little bit more fun. So here we will click on File, Save As, and let me call this app a race thread.java. A race thread.java. Okay, so rename race thread.
Hopefully by race, you don't mean who can type it the fastest.
I type slow, you know that, right? I know you are being nice to me by typing slower, but you can do your regular speed, Greg. I appreciate you being so nice, though.
That's only if my Homer Simpson fingers allow it.
So you would have noticed that as I renamed the race thread class, it automatically renamed the constructor for me. Let me clear out all these comments because that was for the last one to help you understand. That will lessen the code here. So here we have a string called racers. And here's the constructor. Now going to the run method, which gets automatically called by the start, by the way. So what we will do is before we enter the loop, we want the thread, the current thread, to give us the name of the thread. And we can say, okay, the following thread starts. Whoever is the calling thread, because we'll be running several threads. So anytime a thread comes into existence, it first announces itself that I'm starting. And we will not tell while it's running. We will only make it sleep for a second. And we will announce it again towards the end. And we will have racers, that string that I created up there on line number 3, to which we will concatenate the name of the thread that just ended. Okay, separated by the commas. Okay, so that's basically what this method does. Inside the main method, instead of calling unnamed race threads, I would have named race threads rather. Racer 1, Racer 2, and we'll have Racer 3. How about anybody here from McQueen days? Nobody?
Cars.
Yes, yes, yes. Can you tell me one more car? Besides chick kicks and lightning.
Doc Hudson.
Doc Hudson. Hey. Okay. So we're going to try to erase these threads. But the problem is, as we have seen in the past, that they all run at a different pace at a different time. So we will call a special method called join, which will force them to join and not just end at their own time. So we'll make all three of them join and then come to an end. Okay. Now comes the output. Remember, I created this long string called racers up there. I would like to split that into an array based on commas. So that the racers string. Okay. Then from there, I want to print one racer at a time using an enhanced for loop. And it will be printed in the same sequence that they ended. So I'm numbering each one of them as I am printing there. Okay. So the CTR++ is for generating their rank. So let me run. Okay, they all started. It is not notifying me until they all end. Oops. Oh, because of that extra comma. In the end, that's what that does, the extra split. I may have to take care of that differently. Let's do it like this. Integer I equals to 0. I should be racers list dot length -1 I plus racer list I. Let's do that. Here we go. And if I can get rid of that space on line 18. What happened there?
Which line did you get rid of?
Hold a second. I'm just testing something here real quick. Okay, so I got rid of a little space on line number 18 and I rewrote my loop. I had a space after the comma on line 18. It was like this. So I just got rid of that space.
So the join makes them all start at the same time?
No,
Is that right?
Join makes them end. I mean, like wait for each other till everybody ends. It doesn't goes to line number 36. So in the
Okay.
yeah, in the absence of those lines, they will all end and they will jump to line 36. So it just makes them all hold till they are all done running.
it doesn't matter what order it is, right? It's just always gonna be whatever process goes first, right?
It doesn't matter in what order they gets processed, they will always wait for each other. And then they will, when all of them end, only then they will go with lines 36 through.
Can you do me a favor, Saad, and scroll up a pinch? I want to make sure I got everything correct because my erasers is erroring out for me.
Do you have it declared on line number 3?
Hold on a second. There we go. Yeah. Static string erasers. All right, thank you.
Mm-hmm. Okay, so everybody got it?
I got it, but when I run mine, the output doesn't look the same as yours.
I mean, like, how different is it? Like, what do you mean?
It says Doc Cousins starts, the Lightning starts, Chick starts, and then it says they all cross the finish line, but then it doesn't display who finishes first, second, or third.
So your lines 36 through 39 are not coming into play?
Correct.
Okay, do you have line number 18? Maybe you might have missed 18.
Yes, I did.
That's it. So once you put line 18 in there, because with the bottom code is running, but the array is empty. So it's not displaying anything.
All right, let me type this in real quick.
Sure. See, I knew that you could type real quick, and you have been denying that all along.
Yeah. Thanks for the, what is it, the I'm not good with English. The confidence booster.
Well, you know what, Greg?
encouragement.
You can't say. I can't say that because English is my second language.
It's my second language too.
Really?
Yes.
What's your first language?
Broken English.
Mine too. English is second language.
It sucks. It really does.
Ah,
I failed English every year in high school, every single year. And I thought I was done with it. And then I had to take technical reporting last semester. And that was even worse.
Hey, I'm sorry, a little bit late back. My food was finished late, so but I'm back here now. And English is my second language also.
what is your first language? Java?
Creole. We actually sung we sung more Jamaican, I think, where I come from. But it's English too, but it's broken English.
I only know basic French.
Well, you know what? You're better off knowing basic because I've heard a lot of people when they're speaking English and then after a little while they say, excuse my French.
Bonjour.
You're funny as hell, man.
Where's the Rosetta Stone for broken English? I'd like to know.
Well, somebody took that stone away from her.
Saad, I have a question. Do you code and teach in your first language or no?
Do I code and teach? What do you mean?
Like outside of English?
Yeah, I do. I do teach in other languages too. Yes.
That'd be really cool one day if you did that for us. See if we could follow along.
You know, I do it a lot with the telemarketers. When they call me, I speak languages that they don't know. And they're like, hello, sir. Sir, English? Of course. Of course.
Of course, monsieur.
No, I don't use commonly spoken languages in North America or South America. And I don't even use the languages that I know these telemarketers would know. Amka, there are a lot of things that are silent. The S in Illinois is silent for only half of the US, though. The other half says Illinois.
Yeah, just like the word possum. Who calls it opossum? Nobody.
Nobody, right? Yeah.
They're technically different things.
Yeah.
Well, that's nice to know. See, I told you, English is my second language.
At least, you know, we Americans are a lot more descriptive that British don't understand. You know, they make fun of us saying, you know, these Americans don't know where to throw their papers. That's why they call it waste paper bin. Because somebody need to tell them where to throw it away. Otherwise, they were throwing in fresh papers. Similarly, we don't call it horse riding. We call it horseback riding, as if we didn't know where to ride on a horse. Okay, so now we will move on to synchronous and not synchronous threads. That will be our starting point now. Okay. So first of all, we will be writing our code as account without sync. Account without sync. So our thread will not be in sync. So we'll be creating a private class called account. and we'll have a property called balance. And just so that you know, this is what we want to do. We want to create a method which would allow me to add money to my account. And I will give that method to 100 threads. And I will make them all access the method at the same time, provided, I don't have multiple processors. I don't have 100 processors, so they will not be accessing them at the same time, but they will be accessing them very quickly. And then we will see when we let these threads go loose without any control on them and give them the same resource, what they do to that resource. And then we will discipline them. Okay, that's basically this exercise is. That's why I'm calling it account without sync. So there's no synchronization, and then we will synchronize the account. So that's why the example will be done in like 4 steps. So this is only the first step, which is account without sync. So this is my balance property that I am setting to 0. And I will create the getters and setters. And you know how to do that, right? Right? No, but I'm only interested in creating a getter, not a setter. So how can I do that? If I only want to create a getter and not a setter. And I don't want to code. I don't want to type code.
Don't you go on like source,
Yep.
then and then generate getters and setters?
Right. And then only choose what I want to generate.
Right.
By simply clicking on the bottom two buttons. So if I want to only generate getters, I click on select getters, and then I click generate, and it only generates the getter for me. Awesome. Okay. So now let me create a method called deposit, and this is the method that will be.
What did you do? Getters and setters?
I went under the source menu, and I
Yeah, but
clicked.
what did you select inside the getters and setters?
Say it again.
What did you select inside the getters and setters?
I only clicked on select getters button.
Oh, okay.
And then I click generate. Okay. So this is the deposit method, which will be accessed by all the threads, and they will all be sending in money that will be added to the total. So what I will do is I will generate a balance, and I will add the amount to the existing value of balance, and I will store it in new balance. And I'll tell you why I'm doing it. The reason I'm doing it is because what I want to do is, as thread accesses the deposit method, I want the amount which is coming with the thread to be added to the balance, which is existing value of balance. And I'm storing it in new balance, and I am making the thread wait in memory for only 5 milliseconds. And 5 milliseconds is enough time for several threads to come in and grab the previous value of balance before change. And then they all will have an old value, and then I'm going to make one of the thread change it to a new value. So since many threads will still have as old value, when they will write their values to the new balance, it will be old value. So haphazardly, the value will not change drastically. That's what this exercise will tell you when we start running it. So we will make the thread sleep for only 5 milliseconds. And then we will let the new balance give the value to balance. Okay. And then, let me write a catch. I forgot to write a catch here. Catch interrupted exception. Okay. So that's my deposit method. Private static account object, which will instantiate an object of account type. Okay. Now let me create another class, which will be my thread class. And I would also like to introduce one more thing to you guys. If my class is already a child of another class, it cannot become a child of thread class. And that's where your, what comes in? Your interfaces comes in. So implements a runnable interface. A runnable interface works like a thread, except for the fact that it is an interface. It is mainly used when your class already has a parent. But I just wanted to introduce that to you. So that's why, I did that. So when you hover over the class, it will let you add the unimplemented run method. And what this run method will do, it will call the account object, will call the deposit method, and will pass 1 cent or 1 penny. So we're depositing 1 penny on each call by the thread. That's all we are doing. That's why we call it add penny task. I'm not starting the main method yet. I'll give everybody a few minutes to complete this far before we start working with the main. Okay, so let's see. Everybody's done, or people are still coding? Amruta, Aiden, Carter, Arali, Daniel. Okay. Okay. So down in the main method, we will create an instance of a class called executor service. This is a built-in class which will help me execute several threads. So executors dot new cached thread pool. So I'm creating a pool of threads. That's what I told you guys when I was explaining you multi-threading before, that it allows you to create a pool of threads. Now I will instantiate, I'll run a loop that runs 100 times to let loose 100 threads in this pool. So to cut loose, 100 threads of add penny task, okay, which is line number 26. That's a child of thread type. So I am creating 100 threads and let them go, okay? Now, there should be a way to terminate the threading process. That's why we have the executor class. So executor can literally shut down the entire pool or at once. And then we can literally wait till all tasks are terminated. And that could be done with the help of a while loop, where I can say executors dot, or sorry, executor, which is my object dot, is terminated. So as long as things are getting terminated, the loop will keep looping. When everybody gets terminated, that's when the loop will stop. That's why I said not is terminated. And then I will check to see, okay, what is the balance? Now remember, after running 100 threads, where every thread supposedly should be adding 1 penny, I should be getting an account balance of 100 pennies, right? But I want you to run this and check your balance. I only got 2 pennies. Let's see how many you have.
I got 1 penny.
Yeah, exactly. Everybody is different. Everybody will get different outputs depending on how efficiently their threads run. You know, and then I ran it again, I got 3. It will be like haphazard, you know. Sometimes you'll get 1, sometimes you're gonna get 2, sometimes you're gonna get 3, because several threads went and grabbed a value 0. While they updated it to 1, another set of threads get the value 0. And then everybody updated it to 1. Another set of people came in and updated it to 2, but the previous set had the value 0, which updated it to 1. So like that, it just goes back and forth. So there is no synchronization in the process.
Kind of wish we had like a video representation to see what it would look like.
Yeah. Well, since it just does, everybody, it's so random and haphazard, nobody can truly depict. There is no pattern to depiction. It all depends on your processor and number of processors you have and their speed and their availability, that they're not doing any other tasks but this one. Let me clear everybody's feedback. Let me know when you guys are all done with this one, so that I can take this to the next level where we can learn how you can synchronize this code so it doesn't behave like this. And it behaves a bit synchronous. And then we want to take several, see, there are different approaches that you can take to synchronize this code. There's not just one approach. So I want to introduce to you at least 3 different ways in which you can synchronize this code. So who is Aiden, Carter, Arali, Nathan, Alex? Everybody got it? Okay. So let me clear your feedback. And let's save this example as account with sync 1. account with sync1. Okay. And then you must rename account with sync1. So the first approach I will take is this. Who is taking care of adding 1 penny to the balance? Who is taking care of that?
Is it the act.deposit?
It is deposit, exactly. So if I go to the deposit and said, you know what, I want you to be synchronized. Synchronized is actually a keyword. I want you to be synchronized. No haphazard business anymore. Work in sync. This is a great way to synchronize only one method in a class. If not, the entire class needs to be synchronized. And now when you run this, notice 100 threads produce 100 pennies. Everybody runs in sync. No problem. Everybody must have received the output by now. It's only one word that I changed. Now let's look at the second approach. We will save this one as account with sync2. And let me delete the word synchronized from line number 14. What if the entire method does not need to be synchronized? So in that case, you will not have the method synchronized. Rather, who is sending a penny to deposit? Who is sending a penny to deposit?
Is it the account class?
It's the run method, right?
Oh, okay, okay.
Right. So what we can do is we can make this piece of code synchronized by saying synchronized the account object. So anybody who's using the account object, that guy is synchronized. That means no two people can access this guy at the same time. While one is writing, everybody else wait. When it's done writing, only then the second person gets it. So it's synchronized that way. You rename the class, and then you run it. Again, you get 100. That's another approach. Not synchronizing the method, rather synchronizing the call. I'll give probably a minute or so. And that should help everybody get caught up. Okay. Now let's look at the third approach. Let's save this one as sync3. Let me change the name. Okay. This time I will drop the synchronization block on the run method. So I will reinstate the code the way it was before. And that's how the run method should look like. I rename the class and I updated my run method. The approach I want to take this time will be slightly different. In Java, it allows you to have locks. And with locks, you can impose lock on any piece of code, and that piece of code is locked, means it is synchronized. And then you have a power of unlocking anywhere. So you are not locked by the whole method, or you're not locked by the whole block. It's up to you to lock it and unlock it. So you can have your own locking mechanism in place. And that's what we want to do. We want to go back to the account class. In the account class, we want to create a lock object. Re-entrant lock means I should be able to enter in this lock several times. It's not a one-time deal. What I do next is, as I start depositing money, okay, I need to first of all acquire the lock. Acquire lock by saying lock dot lock. We acquire the lock. Okay. Now, there will be some changes in this much piece of code. Okay, so this piece of code will change. First of all, I will push the try block to start here. So this new balance equals to balance plus amount will be inside the try block. Then we'll make it sleep for 5 seconds. And then we will add the balance back. So again, since a lock is placed, all these operations will run and nobody else can intervene and interrupt them. Once this process is done, then in the finally block, I can release the lock. Lock dot unlock. So that's where I can release the lock. Yeah, that's the only change I should make, and I will get the same output as before.
Could you scroll back up?
Yeah. Okay, everybody got this? All set? We have a few more people to give me an okay, like Daniel, Arali, Amruta, Carter. I don't know. Did you guys dealt with any of this in your C# classes, like locks and threading and stuff like that?
Oh, we just started talking about multi-threading in Alan's class this week.
Okay, so you probably have some idea about this then. Cool. It's always good to have this overlap because then it helps you see it from all different angles. Great. Okay. Let's move on to our next example here then, which is about thread cooperation, that how threads can actually work in cooperation with each other. What I mean to say is that I will create two different kinds of threads that will share the same resource. In this example, it was only one kind of thread that was doing the same activity on that resource, right? All threads were trying to do what? Deposit. What I want to do is I want to take this to the next level. I want two different threads to interact with the deposit resource, where one will try to add money, the other will try to withdraw the money. The adding process will be slower, the withdrawing process will be faster. So now what is the possibility of having a problem in this process?
You're gonna run out of pennies.
Exactly. So I got to control this also, that anytime there's a withdrawal come in, I will first check the balance. If the withdrawal is more than balance, the withdrawal has to wait while the deposits will still happen. Okay. When the deposits, after several deposits, when the amount reaches equals to or greater than withdrawal, then withdrawal will take place. And the next withdrawal may have to either wait, or that may also take place if there is a surplus, and if that surplus is equals to or more than the withdrawal. Everybody follow that? What we're doing, what we are about to do? Okay. So we will create a new class, which I will call thread cooperation with a public static void main. I will borrow some of the code from the previous example. Okay. But as I borrow, you can just see, what I'm borrowing, right? Okay. So I will go back to my previous example, which is account with sync 3. And I will just borrow this account class along with the instance of account instantiation. So account class along with the instance of account. Okay. So I'm just copying and pasting that account class here. This is the code that I borrowed. And I'm going to make some changes to it, of course, but this is what I'm borrowing for now.
Sorry, I was creating the class. Can you just remind us which class you took the copy from?
Oh, yeah, I took it from number 3. Account with sync 3. I grabbed the account class
Okay.
and I pasted it.
All right, thank you.
Okay. Now let's start making some
Where
changes.
did you paste it? I
Um,
have an error on my account.
I pasted it right at
Oh,
the
inside.
Yeah, inside the class, of course. It's a private class. Inside spread cooperation class.
Hold on.
Okay. Right above the main, I also have the instance of account type. Okay. Now, remember I told you that we cannot have withdrawal until we have enough amount. So for that purpose, I need to create an object of condition type. I need to pull a condition object. We're going to call this one new deposit. And this will be a new condition on the lock. So I'm creating a condition object. So I'm putting a lock on deposit as before. Okay, but here a few things will change. Instead of having this new balance guy, I will just simply update the balance by the amount. Okay, and let me remove this sleeping business here. And I will notify that, you know what? I received this much amount to be deposited. And after that, I have this much balance. Okay, so I'm calling the balance method from line 13 to give me the balance. So this much was deposited, and that's the balance. Okay. And now what do I do is I call my condition object and say, you know what? Signal all the waiting threads that the balance value has changed. Come in a queue and check if now I have enough balance for you to withdraw. Everybody follow that part? What signal all does?
No, can you restate it real quick?
Yeah. So what signal all does is, remember, the withdrawals will be waiting for me to have enough balance for them to withdraw. So if I do not have enough balance in the account, all the withdrawal threads will be waiting in a queue. So every time a new deposit comes in, the signal all will signal all the waiting threads come and grab the resource. So they will be released from their queues for them to come and grab the resource. Now the new withdrawal object comes in and sees, oh, there's enough balance for me to withdraw. So it withdraws that much amount and exits the memory. And the new withdraw then comes in place to see if it has enough balance to withdraw from. So like that, that process will continue after each deposit. Okay. Does that make sense to you guys? What the balance does, deposit does? Yes, no,
Yes, thank you.
yes, okay. Now we will do something very similar with the withdraw. So this deposit guy is only telling other deposit people to come in and deposit more. Similarly, I need to have a withdraw method, which must also be notified that, hey, come and withdraw more. So for that purpose, I'm copying line 17 through 30 and pasting it and calling this a withdraw method. Okay, so that's a different, so withdraw method also is a locking method, but with a different implementation for the try block. So what does the withdraw method works on? Withdraw method works on the principle that as long as balance is less than the amount that I want to withdraw, I gotta wait. Okay, right? I gotta wait. I can't do a withdrawal because the amount is more than the balance. So I will issue this on the screen and I'll say, you know what? /t/t/t/d. Wait for a deposit. So you can withdraw right now. And how do you wait? The condition new deposit dot await. So this will wait on a condition. And when does the condition notify this guy? Through signal all. Through signal all. Okay. So now what I do when it signals all and I come to line 38 and I grab the next guy in line and it goes and checks to see, oh, the balance is now more than amount or at least equals to amount. So it then reduces the balance by that amount and then notifies that I have done a withdrawal of so much amount. So you know what? After I did my withdrawal, this is the remaining balance. So that's my withdrawal mechanism. So that was my deposit mechanism, that when one thread is depositing, everybody else is waiting. When it is done, it notifies, right? Similarly, I have a withdrawal people that are coming in line and calling the withdraw method over and over again. As soon as they receive a message from condition object new deposit, hey, the resource is available, they rush for that resource. When they rush for that resource, they check to see this while condition. If it is true, they keep waiting. If it is false, they reduce the balance by the amount of withdrawal, and then they notify that this is the remaining amount, and then they go back. Sorry, remaining balance, and then they go back in the waiting state for the next object that comes in. So far, we have only did the methods. We only did the methods. We still need to write those two different threads. One will be a withdrawal thread and one will be a deposit thread. We have not done that yet. So I'm waiting for everybody to be done with these methods, and then I will code those thread classes. So notify me when you are done with this, okay? Okay, so we have Miguel, Amka, Amruta, and Carter. Okay, So now, guys, let's move to the next step, which is to start creating these inner classes that will work with this account class. So let me go down here and start creating my first class, which is my deposit class. So public static class called deposit task implements runnable. And then I will add the unimplemented method run. By the way, guys, is it okay to have an infinite loop?
No.
No. Yes, it is okay to have an infinite loop as long as it is not on your main process. So far, you guys have been trying to run an infinite loop on your main process. That's why your computer has been failing. But today we will learn how you can run an infinite loop on a process or a thread other than your main thread. What is the easiest way to write an infinite loop without using any numbers? Yep, Nathan, you got it. While true. Yep, that's it. Okay, while true. So we want deposits to happen continuously, and we want withdrawals to happen continuously as well. So that's why we're running an infinite loop. And as the loop runs, I want my account object to call the deposit, and I want to add a random number, not just 1 penny. I want to add a random number, math.random times 10 plus 1. And I'm converting it to an integer because deposit expects an integer value. And then since I remember I told you that I want my deposits to be slower than withdrawals, that's why I'm going to make my deposits sleep for a second. So my deposit will be sleeping for 1 second after every deposit, while withdrawal, I will not make my withdrawals sleep. So the withdrawals will be faster that way. I'll give a minute or so to everybody to complete this class, and then I'll move on to the other class. So that's my deposit task class, this one, all of this code. Okay, now I want you to copy the deposit task and paste it right below. For now, you will have 2 versions of deposit task. Change the second version to withdraw task. Withdraw task. So you have the first one, deposit task, the bottom one, withdraw task. In the withdraw task, you will remove the try and the catch and the sleep, right? And instead of randomly depositing, you will randomly withdraw. Oops. Withdraw. You will randomly withdraw the money. That completes that class, the withdraw class. So we're not making it sleep. We are making it run as fast as the computer can run it. Okay. Now we will write our main method. Again, I'll give everybody a minute or so for them to make changes to withdraw task. Then I'll get to the main method.
Hey, Saad, I got a random question for you. Next week, Wednesday, I know the event's going on for the teacher day. Are you having class for this class?
Oh, that's the announcement I wanted to make towards the end of the class, but I can make it now. No, there will be no class next week, Wednesday. So after today, we'll be meeting back on the 4th. And I will give you guys a complete announcement towards the end of the class.
All right, thank you.
Okay, so now moving down to the main method. Remember in the previous example, we use executor service to create an executor. But in that example, which was account with sync 3, for example, we were using the executors to create a cached thread pool. That means we can have a lot of threads running at the same time. You can actually not do that, and you can ask executors to give you a new fixed thread pool. That means I want to fix my executor service to only 2 threads. I want to just have a deposit thread and a withdrawal thread. And then I'll ask my executor object to execute a deposit task object and a withdraw task object. Okay. Then executor will shut down. And then I will have thread 1, which will be, and then thread 2. And the balance. Yeah, that's basically the sequence in which I'm displaying my values. Okay. If you notice, I don't know if you noticed or not, for my withdrawal, I'm using multiple tabs. For my deposit, I'm not. So that my deposit comes under thread 1 and my withdrawal comes under thread 2. So that way you will be able to see the sequence in which they will be running. So let me run this. And let me stop this during execution because it's an infinite loop. Will keep running. So this pretty much shows you a good example, a good picture that how these threads are running. So first of all, there is a deposit of 3. Okay, so the balance is 3. The first withdrawal comes of $1 or 1 penny, whatever unit you have. And since 1 is less than 3, that's why the withdrawal went through. And the remaining balance was of 2. Another withdrawal came for 2. There were only $2 in the bank account, so 0 was left. Another withdrawal came, but since there was $0 left in the bank account, that withdrawal was asked to wait. A new deposit of 6 was made. Since the waiting withdrawal was only for $5, that withdrawal took place and the remaining balance was 1. And new withdrawal came, and since it was asking for money, more money, right? That's why it had to wait till a new deposit came in. So 10 was the new deposit. Existing balance was 1. It is the 11 that's sitting in the balance now. So 2 withdrawals could easily go through because both withdrawals were less than 11 or equals to 11 together. And then we had to wait for another withdrawal, another deposit, I mean. So like that, it is going on. I don't know if did you guys follow that sequence?
Formatting could have been a little better, but yeah, I think I followed pretty well.
Okay.
I have a question. Can you scroll up a little bit? I'm having a problem. I'm having an error on my catch for the in a deposit for some reason.
Okay, everybody got it or still having errors?
I have had an error before.
Say it again, Amka.
I have had an error before, even before like we get onto the main. You
Oh,
want to see it?
okay, hold on a second. Let me, okay, you can share your screen now.
I had an error. Two things.
The screen is still loading on my end, so as soon as it loads.
Yeah, my internet is so bad.
No, that's fine. That's fine. Okay, so it is
I
not,
have it in this one and this one.
it is unable to see a method called deposit. That's what the complaint is all about. So you need to go into your account class. Scroll up.
Account. Okay, right here.
You do have a deposit method. Okay, and
Mm-hmm.
scroll down. A withdraw method. Okay, now scroll back down. Scroll back down. Okay. Oh, you are missing a parentheses after the T of deposit.
Oh.
Okay. No. After the T of, yeah. That's it. And then let me see, you're balancing your, you have a math.random.
This one too, right?
Oh, yeah, after 10. After the 10, you need a parentheses.
This one?
Let's first fix line 65. Okay, yeah. So now you can, now you can copy line 65, whatever is between the parentheses for deposit, all the way. No. Only copy what is it, whatever is after the word deposit.
This one?
Yeah, start from there and to the end of the line. Copy that. And yep, and replace whatever is after withdraw. Yeah, and get rid of that extra parentheses you have after withdraw. Yep. Okay. Now, get rid of line number 80. We do not have that line there. Okay, cool. Now save the changes and run. Okay, cool. Now you can hit that red square. Yep, otherwise your program will just keep going forever. So
All right, thank you.
it does, okay? Everybody else is done with this one? Okay, silence means probably yes. So let me share my screen again. As I told you guys that we will not be meeting next week because of faculty training. So under unit number 3, this is what we dealt with, multi-threading and JCE. We did not get to Java network programming, which we will take care of next week. Sorry, not next week, 2 weeks from now. So you have 2 quizzes to do, and you have 2 assignments to do. And all 4 of these items are due by the 4th. Assignment number 2 is about a Java FX application. And assignment number 3 is about a multi-threaded application. Similar to what we did in class, but slightly different variation. So you need to write a program that launches 1,000 threads. Each thread adds 1 to a variable sum. Sum will initially be 0. And then you will run the program with and without synchronization to see the effect. So you will write the solution without sync, and then you will write the solution with the sync. You can pick any of the 3 sync approaches I taught you. You don't have to do it 3 times. Just any one of the 3 sync approaches. And that will be your assignment number 3. And then there are a couple quizzes that you have to work on. And all 4 items are due by the 4th.
Lord be with you.
Jonathan is asking about the recording. Jonathan, recording, I don't know, maybe tomorrow?
Okay, thanks.
It all depends.
Yeah.
Yeah, it takes a few hours for it to be done. So probably tomorrow.
Okay. That works.
No problem. Okay, guys. Then I'll see you guys, some of you tomorrow afternoon and others in a couple weeks.
Yeah, see you in 2 weeks.
See you in 2 weeks.
See you tomorrow morning.
Yep.
Have a good night.
Good everyone.
Bye.
Night.
Bye. Night.
Excuse me, Mr. Saad, I have a question for you.
Yep.
Okay, so are you expecting same registration form which you provided as a sample?
No, it was just a sample. The
Sample.
has to be your idea of a registration.
Oh, okay. Okay.
Okay.
Okay, thank you.
No
Thank you.
problem. Okay.
Okay, have a good night.
You too. Bye.
Okay, bye.
Whoa.
Yes. Mark.
I just have one question.
Mhm.
So on the quiz, it asks, well, the first question asks me, what is new in Java effects, right? So is it asking like comparing to swing or is just like entirely that it's just what the newest update? What do you exactly mean when you say that?
Is it quiz number 2 or 1?
I think it's 1. The one that's due tonight.
Oh, the one that's due tonight. Okay, just hold on a second.
I'm just confused with the question, that's all.
Okay, just 1 second. Let me refresh my memory. Oh yeah, that is a detailed response, right? So yeah.
So you gotta write down what it is. I just don't know what you mean by that.
Yes. What are new things that are introduced in Java FX compared to Swing?
Okay, good. That's what I thought. Okay. Okay, cool. And then yeah, I think it's and then for the GIF, does it have to be exactly how it looks like for the assignment?
No. That was a
Because I got the title of it and the radio box. I just gotta put a scroll bar in there and then that's it.
That was a sample to help you guys visualize something because some people ask for some visual samples. You don't have to create exact that. It has to be your design.
Oh, really? So I was completely implementing it. Like, can I show you what I have? Then is it fine?
That's why the file I gave you even says that sample. And even if you look at the assignment in the note section, I said attached you will find a sample registration. It's a sample. You don't have to reproduce exact same thing.
Let me just can I just show you what I have? And is that okay?
Yeah.
This is what I got. See?
Yeah, that's fine. Works.
This is good?
Yeah.
Okay, awesome. All right. That's all I wanted to know.
Yeah. Awesome.
Okay, well then thank you and see you in 2 weeks.
Yep. Take care. You too.